This year has been a wild ride for AI progress. And as we wrap up 2024, here's some notable figures that kind of give their take on what we've been through and what's to come. Let's take a look at AI leaders like Andrew Ng, Dr. Jim Fan, and other researchers and educators that talk about what they believe is coming next, what they've been very excited about in the past. Here's one of my favorite AI and robotics researchers out of NVIDIA, Dr. Jim Fan. A lot of stuff they did early on with ChatGPT, him and his team were just absolutely mind-blowing. Eureka, that was one of his projects. The Minecraft Voyager, that was one of his. And now they're doing the Groot project, which is focusing very heavy on robotics. NVIDIA is, of course, kind of well known for training these robots in simulation. So where time flows, at 10,000 times kind of what it does in our universe, so to speak. But all of the physical laws and friction and gravity, etc., are replicated very, realistically, very lifelike. But time flows at 10,000 times what it does here. And so they throw a bunch of these robots in a simulation. And these robots, they train themselves how to pick stuff up and do various tasks. Then we take that learning and we're able to put it into real life physical robots. And that's sort of what they call sim to real kind of transfer. Seems to be working really, really well. And here Dr. Jim Fan is kind of covering some of the things that happened this year. He's saying, say AI one more time and we'll end 2024 for good. It's been a wild ride. I like this saying, the year went on like a diffusion model. We watch our sci-fi visions gradually denoise and materialize. So let's celebrate one line each, lightning round. Are you ready? All right, so we have a couple of chapters here. So chapter 1, robot hardware. We are the last generation without advanced robots everywhere. Everything that moves will be autonomous. So this is the same thing he was saying earlier. And here's why we should be so excited about this. So rise of high-end humanoids. The reason that a lot of people are building humanoids is because the world is built for us, for that shape. All the facilities, appliances, and tools are designed, are form factor, right? So if you think about it, a lot of things are built, to be used by a hand with 5 digits, etc. So we have the Tesla Optimus. Very few humanoids companies have the courage to show live interactive demo in the wilds. Tesla did it at the We Robot event. Gen 3 hand, 22 degrees of freedom. It's very much ahead of the game. By the way, if any of you know exactly, was it teleoperated during that event, the bartenders, or was that, completely sort of autonomous, etc.? If you know what the breakdown was, like the dances probably were kind of pre-scripted. Were the bartenders teleoperated, or was that completely real autonomous behavior by the robots? If you know, please let me know in the comments. I know there's a number of people saying different things about that, so I'm not 100% sure. Then we have the 1X Neo, friendly neighborhood humanoid aiming to deploy massively at homes. Boston Dynamics Atlas, the heavy-duty champion, 160-degree joints unlock some insane gymnastics. Figure, fast iteration speed from prototype to car factory deployment. So they're, working for BMW, probably building cars either now or very soon. 4-year intelligence, GR1 robots are one of the few in mass production. So thousands of them are being shipped worldwide. Clone, Westworld-styled design, biomimetic muscles and tendons. A fresh new perspective on how humanoids can materialize. Have you seen this thing? Their little commercials for the robot, I gotta say, is kind of wild because it seems a little bit more like a movie trailer for some like horror flick than it does for a tech company. So this is Clone Robotics. I should probably give them a follow. And so here's kind of what that's looking like. I mean, is it just me or is that a little bit disturbing? You know what I mean? I mean, it looks like why is it twitching like that? And where are the legs? They're coming soon. But yeah, I mean, it's absolutely an incredible feat of technology. But something about that just kind of creeps you out a little bit, doesn't it? It's very cool. Oh, God. Yeah, see, this is a horror flick, but still very impressive nevertheless. All right, I'm going to keep going here. Let's continue. So that one was Clone, and I'm sure no one will have nightmares for life because of that. But continuing, rise of inexpensive robot hardware. Cheaper than cars, highly scalable, very affordable to most middle classes in the near future. This is what's really interesting to me, because this is not going to be for the sort of the upper class, ultra wealthy individuals. just like with everything new technology, when it kind of rolls out, sort of the people with a lot of, extra money, disposable income, etc., in a way, they finance a lot of these, right? So first of all, you start selling to people with a lot of extra cash on hand, so to speak. They finance that, but that's sort of, it helps continue kind of the manufacturing cycle. And eventually the costs come down and eventually you're able to get it to more and more people. So we're probably, just because of the sort of the scale and the incentives to get this out to as many people as possible, we might see that process happen a lot faster, especially since companies like Tesla and NVIDIA, et cetera, they have a lot of money to throw at this. So we might be seeing some of these robots be very affordable to middle-class families very, very soon. Next, we have the Unitree G1 humanoid, so around 40,000, weighs 77 pounds and stands 50 inches tall. Small but mighty in agility. Also, if it goes rogue, I feel like, that's manageable, right? I mean, if it was like 200 pounds of metal, like I'd be a lot more concerned. You know what I mean? This is, I don't know. I feel like that's manageable. Then we have the Unitree B2W. So kind of if you've seen those little robot dogs. So robot dog with 4 wheels that outmaneuvers most animals on Earth. So you might have seen this thing, a robot dog with the 4 wheels doing all sorts of interesting tricks and whatnot. It's able to navigate certain terrains. Here's an example of that incredibly, incredibly well. I mean, look at that agility. I gotta say, yeah, it's probably either close to exceeding most animals or already definitely exceeding most animals. There might be probably some like mountain goats or whatever that they're still as agile, but we're rapidly approaching a time when it's going to be more agile, faster, and just more accurate, able to scale mountains, all sorts of terrains. I mean, that's a pretty impressive abilities that it's showing. And keep in mind that a lot of this is trained in a simulation. So it's not like there's some computer scientist sitting there going like, this is how you jump over a rock, or this is how you go down this hill. None of this is quote unquote programmed, right? We throw them in a simulation and it tries a million different ways to navigate this stuff. Every time it falls on its face, it gets a -1 point, some sort of a negative reinforcement. And every time it successfully navigates an obstacle, it gets +1. And over millions and perhaps billions of these iterations, these simulations, it slowly figures out how to do that in this video game, in this simulated reality. And then its neural nets, its brain sort of learns that. And then we're able to take that data, put it into a real life. I now really, really want one of these. Wouldn't you? Anyways, then we put them into the real physical robot, and it works. This sort of idea of going from simulation to real life, real world is working really well so far. So Aloha, so this is the thing that I was talking about in the beginning, where we might be able to start building some of the stuff inside our homes with these little kits. And I think Aloha was one of the things that really kind of signified to me that this would be possible. So first of all, this is kind of what it's looking like, and they have a full-blown version that's able to move and roll around. A lot of this stuff, you're able to train it at home with teleoperation, but it kind of learns to generalize a little bit. So here's an article on it. So it learns to cook, clean, do laundry. So you start with teleoperation by doing the things for it, and then it's able to kind of pick up on how to do that and actually complete those tasks by itself. But here's the thing that kind of jumped out at me. The entire setup, which includes webcams and a laptop with a consumer-grade GPU, costs around $32,000. Which is much cheaper than the off-the-shelf, sort of the more expensive robots, which can cost up to $200,000. A lot of the code is on GitHub, including all the parts you would need, how to run the simulation, all the code that you need for that, etc. So we're getting very close to where we can start kind of building our own. It's only going to get cheaper. It's going to get easier, right? There's going to be more and more tutorials on it. So at some point, it's possible that young kids might be kind of doing this as a hobby, building robots to take care of their chores, picking up the room or whatever, picking up after the dog, weeding the garden. That might be a thing that we're going to be seeing emerging over this next decade. We have Apple Vision Pro, so it plays an interesting role in robotics as a data collection device, parses your head and hand poses in real time, controls the robot to mimic your action. Then we have various embodied AI, right? So we have the Tesla full self-driving, which is the largest physical AI data flywheel in history, right? Because all the cars on the road, all the Teslas are constantly scanning, gathering data, which is improving their ability to drive. So the more it drives, the more data it collects, the more cars there are on the road. So it's kind of like a flywheel effect of improving and compounding its abilities as more cars are driving more miles and getting better. And it's interesting, he refers to it as a powerful photon to action neural net. Then, of course, we have Project Groot. So I believe Dr. Jim Fan is either the lead on that or one of the leads. So Project Groot is a moonshot initiative to build the AI brain for general purpose robots. Jensen walks on stage at the SAP Center with 10 humanoid robots in the background. And then we have Hover. Our team trained a 1.5 million foundation model that learns how to coordinate the motors of a humanoid, capturing the subconscious processing that our cerebellum does every millisecond. So 1.5 million, I'm guessing, so 1.5 million parameter foundation model. That's very, very tiny. So interestingly, for things like the GPT, the large language models, it's kind of like slower processing, but capable of doing more complex tasks. But our brains, a certain subconscious processing happen quickly without us realizing it. It's not very complicated, but it just needs to happen constantly, needs to happen very fast. So sounds like this is something similar, but for robots. Dr. Eureka, we've covered this, and I don't understand why this didn't get as much attention as I feel it should have. So their team trained a robot dog to balance and walk on top of a yoga ball purely in simulation, and then transferred zero shot to the real hardware. A large language model automatically writes the reward function and tweaks the parameters so we can watch Netflix and still get work done. So Eureka and I guess Dr. Eureka, they actually, in the paper, they use GPT-4 to write these reward models. Then it would be used to train those robots in simulation, the results given back to the GPT-4 model, and GPT-4 model will be told to see if it can improve somehow. So it's this iterative process of AI, GPT-4, a large language model, writing reward code to train robots in simulation and then iteratively improving that, which is kind of wild to think about. And the other thing that they've noticed is as some of these tasks get more and more complicated, there's a divergence between kind of the reward functions that the humans write, and these humans are, best in class robotic engineers, machine learning engineers, etc. And there's a divergence between them and GPT-4, the kind of reward functions that it writes. But it's actually better at doing some of the the more difficult tasks than humans are, which would suggest that, once these things get a little bit more complicated, that AI is going to be not only able to come up with novel solutions, so new solutions that humans can't come up with, but those solutions will also be better than what we can come up with. So at some point, AI research and robotic research will largely be driven by AI as opposed to kind of like human intelligence. And then this PIO from the startup Physical Intelligence, a robot vision language action model, VLA, that performs impressive multi-step tasks like laundry folding, love it, uses Aloha Setup for cheap data scaling. We have OpenVLA, Stanford work on open source VLA model, trained on the OpenX embodiment dataset that aggregates robot motion trajectories from labs around the world. We briefly covered this in a previous video. And of course, we have the computer hardware, right? NVIDIA. So Dr. Jim Fan works for NVIDIA. NVIDIA, of course, the biggest AI hardware company on the planet. Scaling up, NVIDIA introduces Blackwell architecture, a new beast in town. DGX GB200 crosses 1 exaflop compute in a single rack. But also scaling down, this is kind of one of the somewhat newer trends we've seen, right? So as we're scaling things up and making the models bigger and the chips bigger, we're also seeing a lot of progress through scaling stuff down, through making stuff more efficient, more compact. Sometimes that means maybe making it just a little bit more narrow in what it can do, but sometimes just certain approaches tend to be more efficient. Like, for example, with the DeepSeek model, they were able to, out of China, they were able to train it for something like 11 times less the compute cost than, for example, Meta used. So we're seeing a lot of possibilities and potential in scaling down. And here, the Jetson Nano Super, 67 TOPS of AI computing in a $249 mini box designed for running small, large language models on edge devices like robots. It's NVIDIA's Raspberry Pi moment. So if you haven't seen this thing, so this is kind of what that's looking like. It's a fairly small device. It runs large language models, and it can be used on what they call edge devices, so robots. But there's tons of other applications. I mean, you can run something like this in your thermostat, in your car, in whatever you're doing. If you need something that's like small, efficient, not necessarily online all the time, then something like this is going to kind of provide that use case. Then, of course, we have the Google Willow chip. So this is the quantum computer chip that Google announced recently. So they used one of their alpha system, Alpha Qubit, I believe it's called. They figured out how to correct for the errors that quantum chips make. So it's a neural net that corrects the errors of these things, which allow them to create the Google Willow chip. And something like that is incredibly powerful if we're able to sort of find the right use cases for it. Because, for example, the stat that they sort of said is in 5 minutes, it would be able to solve a puzzle that would take one of our supercomputers currently, 10 septillion years, which is, if you take the entire sort of lifespan of our universe, that would be billions of times of that. So it's however many billion years we've been around, it would be that times billions. That's how long it would take a supercomputer to solve a problem that would take this sort of quantum computer 5 minutes to solve. Now, the big problem, the other side of that is we don't know exactly where to use it, right? Because it's really cool for benchmark purposes. We still haven't found like a real world application for it that supercomputers can't do, that this is like uniquely capable of doing. So we found a solution for something, but we need the problem for it to solve now. So that's kind of where we are. But still, it's incredibly impressive, and it's going to be potentially unlocking a lot of avenues down the road. So as we kind of like do more stuff in that space, this is certainly going to be probably going to give us a lot of breakthroughs down the road. And then, of course, we have video generation and world modeling. Sora, of course, from OpenAI. As he says here, it lost some charm due to the long wait, which is very, very true. But, as we've covered in some of the previous live streams and videos, like it's very impressive in a lot of different ways, especially when you start looking at some of the details. Like, for example, if you're looking at something that has reflections, if there's reflective surfaces or liquid that reflects, for example, the sun or some sort of light, it captures that incredibly, incredibly well. And for it to be able to reflect something in a mirror, if you think about it, there's one specific shot that I was talking about where there's a wooden table that's polished and very reflective, and then there's kind of a TV screen above it, but it's reflecting a part of the TV screen that you can't see because it's kind of underneath it. So in order for Sora to produce something like that, even though it's producing just a 2D image, it has to have some sort of representation in its kind of latent space about what that 3D object would look like. In order to understand how shadows and lights and stuff reflect off various surfaces, it has to understand how, light and shadows work. So it is, thinking of these things as video generation, I think is a little bit sort of missing the point. They are modeling the world. They're modeling physics and light and 3D spaces. And we've seen some studies, one out of Harvard, I believe it was called Beyond Surface Statistics, that have, I don't want to say proved, but certainly showed very strongly that these models create some mental model of the 3D space that they're trying to build. So we feed them 2D images, right? Because if you think about it, if you're looking at a computer screen, that's a 2D surface, right? So if I show you some picture, right? If I show you this image and I ask you, what is in this image? Like, what is the main object of this image? What is the object in this image? You would say, well, it's the car. And if I say, what's closer to you? You'd say, well, like the grass, the front of the car. What's away from you? Well, this hill, the sky. But the thing is, if you think about it, this is not a 3D image, right? It's a 2D image. It's flat. The only reason that we can make sense of the 3D-ness of it is because we've seen this in the real world, right? But if you're feeding just 2D images to a neural net, to an AI model, it's not obvious that it would at some point just understand 3D space. But this paper out of Harvard, Beyond Surface Statistics, kind of shows that it figures it out, right? So they take this model and they feed it a bunch of 2D images. There's no depth data in those images. So they're not explaining to it what's near, what's further away from the camera, quote unquote. They just feed it images. And eventually it's asked to reproduce or create new versions of those images, right? So if it's shown a million images of cars, later it's asked to produce a car, and it produces kind of a new car. It just doesn't spit out one of the existing things in its data, kind of produces a new, what it thinks of a car, what that looks like. But what they found by looking at how it produces those images is very early on in the process, a couple interesting things happens. Number one, it has some internal representation of the salient object, which is the salient object would be in this picture, the car, right? So like the main object in the frame, right? So it kind of knows like, okay, the main thing goes here, right? And you can kind of see it. It's one of the first things that it kind of thinks about. And also it understands depth, right? So the red is something that's closer to you and the blue is something that's further away, right? So very early in this denoising process, as it's creating the image, it understands that this wheel is closer to the camera and this background trees or whatever that is, that's further away. And so when they're saying it's learning implicitly, that's what they mean. We never taught it about depth. We never taught it about 3D-ness of objects. We just, hey, here's a million 2D images. And implicitly, it somehow figures out that, okay, there's some 3D space that I need to be aware of. And there's some sort of implicit learning going on. And so that's kind of important why Dr. Jim Fan is saying here, video gen and world modeling kind of in the same thing. So Sora, yes, it's a video generation, but it's a world simulator, right? So as he's saying here, Sora is a text-conditioned, soft simulation of the visual world. The model learns intricate rendering and intuitive physics, all by some denoising and gradient maths. So it's like if you have a puppy and you start throwing it a ball, eventually it figures out how to catch that ball and how the ball moves through the air, even though it has no idea of physics or gravity or momentum or anything like that. It builds kind of a mental model for how that ball is going to move through the air, what it's going to fall, etc. In a similar way as these models observe the massive amounts of videos that we feed to it, it kind of understands some intuitive understanding of physics. In this case, some intuitive understanding of depth and kind of 3D objects and what is the salient object in this frame, for example. This, I think, is the thing that the people that don't get the thing about AI, what it is, like this, if you can grok that aspect of it, I think that's kind of like the biggest thing to understand about it. The people that say, oh, it's just data in, data out. No, we're past that. Next, we have Veo. As OpenAI delays the release, Google stages a great comeback with a more accurate physics and fine-grained object dynamics. Certainly the camera controls a lot of the physics in Veo. I mean, Google just took a massive leap forward across so many different domains in AI, and Veo is certainly one of them. Action-driven world models, yes. Game engine, yes, you can run Doom literally anywhere, even inside a diffusion model. So this is where they ran Doom, the old 1993, 95, whatever game, but instead of running it on code, it was running inside a diffusion model. So as the player is pushing buttons on the controller, like to go forward, to go shoot, to open a door, this thing would generate almost like a video of, it would predict what would happen in the game. So the game isn't running on code, the game is running inside of this neural net that's like in real time showing you frames of what would happen as you're pushing the buttons. Same thing with Oasis and Minecraft. And Genie 2, I believe that's Google as well, where you can run more games with joystick controls inside a diffusion model. So we're seeing more and more of this idea of that we're able to create simulations using neural nets. Then we have a World Lab, startup led by Fei-Fei Li, who is a well-known person in the AI space. I believe she's an advisor to Dr. Jim Fan and many other prominent AI researchers. And they have a stunning demo of a generative 3D foundation model with strong geometric consistency. So we've covered it. Basically, you can take any image, throw it in this thing, and then you're able to, the model creates kind of a 3D space, and you're able to use your WASD and the mouse to walk around in that image, whether that's some, fantasy landscape or, just a regular photo. kind of creates a 3D world around it. And of course, large language models, right? So Claude Sonnet 3.5 shocked a lot of people with not only coding abilities, but a lot of other, frontier abilities. Gemini 1.5 Pro, 10 million context length. This was a big deal. So it learned in context. So a lot of the stuff these models learn through training, right? We give it tons of data and it comes out knowing stuff. But here, this is a little bit different because it's learning from context. So after it's trained, we give it a bunch of texts from this almost non-existent language, or at least a language that's not really present on the internet, right? There's less than 200 speakers. And from these sort of 500 pages of tutorial dictionary, it's able to learn how to speak that language just from in-context learning, which is kind of how humans learn. So this is kind of a big deal, kind of an interesting emergent ability. As Dr. Jim Fan puts it, learning happens on the fly in fast neural activations instead of slow gradient descent. So instead of like that training process, it happens on the fly once the model's already trained. O1, Project Strawberry, of course, this is the inference time scaling or test time compute or, think before you answer, kind of those hidden chains of thought, whatever you want to call it. This was, of course, when we heard the rumors about Q star and all that stuff. I think the O1, the Strawberry Project, like we're pretty certain that was what that was referring. And this is kind of like the version of it that they released. And then, of course, O3, comeback of reinforcement learning. Give me a reward function and I shall move the world. The essence of O3 is about relaxing a single point reinforcement learning superintelligence such as AlphaGo to cover more points in the space of useful problems such as math and coding. And again, back in the kind of the Q-Star leak back in November 2023, we've covered a lot of this ideas, right? Because we had incredible models coming out of Google DeepMind, most of them called Alpha something, AlphaGo, AlphaQubit, AlphaCode, AlphaFold, etc. And they had a certain approach, right? So they had kind of a reward function. Oftentimes they had self-play. So they had this model kind of searching through many different avenues to find the most optimal approach to some goal that it had, right? And then on the other side, we had OpenAI driving at the time, having GPT-4 at the time, the king of the large language models. And it was also a very powerful AI, but very, very different from the kind of the alpha models. And so at the time, there was a lot of speculation that, looking back at it now, we know that it was correct, right? A lot of it was correct. The idea that now both of these companies, the next big thing that they're kind of all working towards is the combination of the two, right? You take the best of what GPT-4 was, of what these large language models were, combine them with all the ideas behind some of the models like AlphaGo, AlphaFold, all of those models. And the combination is going to be kind of that next big leap forward. And we're just at the end of 2024 beginning to see kind of that emerge. Now, of course, we think that, Ilya Sutskever, that famous saying, what did Ilya see? Now, Ilya Sutskever is saying that there's a straight shot to ASI, artificial superintelligence, right? A lot of the things that we believe they saw in November of 2023 was this. This is what spooked a lot of people because they're like, oh man, we're so much closer to a very powerful superintelligence. We're much closer than we thought before. And so I think we're going to be seeing some nutty things coming out of this kind of approach in 2025. It's almost scary to think where this is going to go because, like, for example, in terms of math, it's absolutely beating the human benchmarks, the best mathematicians and the AIME, the IMO. Google's model almost got the gold medal on the IMO, the International Mathematical Olympiad or Mathematics Olympiad. And of course, they're pretty much getting close to 100% on the AIME, the other high-ranking math Olympiad that's just under the International, the IMO. So there's a company that's building a new set of benchmarks that's like beyond anything that humans understand in terms of math. Like it's so much more past what we would grade humans on, specifically for these AI models to be benchmarked. So they're exceeding human level ability to the point where we have to create these new benchmarks that are past human level ability for us to be able to even understand how smart these models are. So, and I think a lot of that is coming, or we're seeing that with the O3 models, the O1, the O3, kind of the reasoning models. And number 5, this is the true AGI test, is to complete the sequence. If an AI model model ever figures out the answer to this, we would certainly call it AGI because it's beyond any human level mind to grok this, right? So if you start calling something GPT 1, 2, 3, 4, right, you can kind of complete that pattern. GPT 5, GPT 6, right? But no, the next one is 4.0. What comes after 4.0? 0.1, of course. Okay, what comes after 0.1? You thought it was 0.2? No, it's 0.3, obviously, right? What comes next? No one knows. No human mind other than apparently Sam Altman can possibly figure out what comes next. And then we have the human AI interface is a criminally underrated topic. Large language model capability envelope is way ahead of UI, UX design to unlock the full potential of such capability. This is interesting. I mean, I'm kind of thinking everything is going towards certainly voice assistance. And maybe, if Google is trying to do their project with the glasses to where you're able to see and it's able to project stuff in kind of a augmented reality space, that to me seems like the final human AI interface, at least until we kind of like jack those things straight into our brain. Some sort of a brain computer interface would probably be the final step. But certainly, yeah, it seems like there's a gap between what they're able to do and how well we're able to like interact with it. Certainly, typing in questions into a chatbot seems, yes, he puts it like it's a criminally underrated topic. I have to agree. And the rise of real-time speech models such as GPT-4o, advanced voice mode, is a one-stage distillation of a traditionally three-stage process. So it used to be that when we had these voice assistants, and I've showed actually how to build one with code back in the days, but it'd be like a Frankenstein. You would chop different pieces of different models together. You had OpenAI's Whisper that would transcribe audio to text. Then you can use something that would do, text to audio. Then you would do GPT-4 somewhere in there. So you would say something that would get transcribed to text. That text would be fed into the GPT-4 model. Then the GPT-4 model would respond with text, right? Then that text would be read out loud by some text-to-speech, the TTS model, right? So it would be this like centipede, like LLM centipede thing, pardon the reference, that you would need to sort of stitch together to be able to do this. Then GPT-4o comes out, right? And the O stands for Omni, as in all, right? So it's all in one. It's trained on everything in one with voice and, like hearing audio in, and, text responses, etc. That's why it sounds so good. That's why it sounds so realistic. That's why I can sing. Now, it's normally not going to sing for you if you ask it, but if you're like extra charismatic, if you're extra good at getting it to do stuff it doesn't want to do, then it will actually sing, and it's really good at it. And it's going to be able to do any lyrics or anything like that. It's just due to some like legal issues there. It's not allowed to do it, but you can break it a little bit to make it sing. Which, try it out if you can. It's an interesting thing to hear. NotebookLM. I was blown away by NotebookLM and how quickly they iterated and improved. So now, for those of you that don't know, you basically take whatever PDFs or data or research subjects and you just like throw it all in there. Whatever kind of material you're doing research on, you just throw it in one place. And then you can just ask questions about all of it, or it can generate a audio podcast for you with two hosts, which sounds great. It's phenomenal how good it is. And now the most recent thing is you can actually like how you could call into radio shows and ask questions. You can do that to the podcast. You click a button and they go, oh, we have a listener who wants to ask us a question. And you speak into the microphone. You're like, oh, how do you do this? Or something along those lines. And they will answer that question based on all the stuff that you've uploaded. Again, PDF files, YouTube videos, audio files, websites. You can even copy and paste text in, just kind of whatever you want. It's kind of mind-blowing, and it's very exciting how good it is, especially with the Gemini models that are very good at that kind of needle in a haystack search. Because I've been testing it out. Back in the days, these models would be very bad. Like if you gave them a 100-page PDF and you were asking about some specific thing that's kind of buried somewhere in the middle, it would be very bad at picking that information out. With these Gemini models and whatever's powering NotebookLM, some Gemini model, right? It's really good at that. More often than not, those little needle in a haystack questions, it tends to nail it. It's very good at it. And then we have the open source community, Andre Karpathy, LLMC, right? Karpathy crunches tokens in naked C, no Python, no frameworks, no dependencies, just raw math, talking to bare metal. He writes poetry and code. Andrej Karpathy is building some sort of a education about AI. I think that's his new sort of maybe startup or business or idea that he's trying to build up. And certainly wishing him the best of luck. Very interesting where he's going to take that. Next, we have Llama 3, the power of GPT-4 in the palm of your hands. Llama and Meta and the open source models they've been producing are just incredible. How powerful they are and how available they are. One of the research papers showed that you can use one of the smaller Llama models to tell it to basically infinitely replicate itself. Like you say, hey, figure out how to replicate yourself on this new server, and then tell that model to replicate itself on a different server. So there's certainly some red flags and some security issues that we have to think about. But certainly open source AI is kicking butt. I got to say, it's doing incredibly well. We've thought there would be this massive lag between the sort of proprietary big tech models and the open source models, and that's just not the case. We're not seeing that gap is razor thin. Maybe that's overstating it a little bit, but certainly that gap isn't massive, right? Next, we have DeepSeek. So this is the company out of China that's been releasing several just incredible models, both approaching the O1's reasoning abilities with their model, but also the most recent V3, where they were able to create this incredible model with massive resource constraints, right? As Dr. Jim Fan says, shows that resource constraints force you to reinvent yourself in spectacular ways. So again, it's like 10 times less what Meta used in compute costs. So it's showing us that these things can be a lot more efficient than we realized. And of course, AI for science, the Nobel Prize in Physics, right? So he's saying, today we are all physicists, AI PhDs, read my Hitchhiker's Guide to Rebranding. Machine learning is now statistical mechanics. You are eligible for the top award now. And of course, the Nobel Prize in Chemistry, right? So Demis Hassabis and the AlphaFold team with the breakthroughs in figuring out how the 3D structures of proteins fold, a massive breakthrough. And we're probably going to be seeing some absolutely incredible medical breakthroughs that come out of that. Custom medicine, custom designed proteins, etc. As Demis Hassabis says, we might see the eradication of, he probably meant either most or all disease, I'm not sure, but it's going to be massive. And yes, so as Dr. Jim Fan says here, solve AI first and then use AI to solve everything else. This is kind of like the big theme of this, it seems like our human intellect got us this far, but a lot of the future breakthroughs will likely be pushed forward by neural nets, artificial neural nets. Of course, Neuralink, right? We've seen the Neuralink installed, where basically it's a machine-brain interface, computer-brain interface. And we've seen the person, I'm forgetting his name, unfortunately, but he's playing Mario Kart, he's playing Civilization, he's playing all sorts of stuff. He's able to use the computer. He can't move any muscles below his neck, but just by thinking about the mouse movements and stuff like that, he's able to interface with a computer, able to interact with a computer, and at a fairly good level. He's not able to move and click on things as fast as some 15-year-old kid gamer, for example, but certainly probably as much as the average, maybe non-tech user, kind of as fast as that. And this is just, the earlier versions. Certainly I could see how with progress, he might be able to interface with computers much faster than any other human could in the future. And so in closing thoughts, there are many, many great AI moments that he couldn't possibly enumerate in this post. Can't believe it. It's already been 2 years since the debut of ChatGPT, which is, if you think about it, 2 years and 2 years and change. And it seems like a decade. And 7 years since the Transformer paper. Lots of hype, promises, and fears. I tried my best to improve the signal to noise ratio for my audience. By the way, that's not me. I prefer to think of it as a fire hose of information that I just try to cover to the best of my ability. But certainly it's excellent to hear Dr. Jim Fan when he posts on a particular topic. It's always great to hear his sort of take on it because, he does sort of really do a great job of reducing it to the essential, and very oftentimes points out certain things where sometimes it pulls back the hype a little bit. Like you think, oh, this looks amazing. But he makes like a little correction. Like, actually, it's not quite this. It's a little bit different and still amazing, but it kind of a little bit more realistic. And that's what I look to him for oftentimes, for that kind of, incredible insiders insight on a lot of these subjects and topics. And he says, I'll end with this Wilson's quote, which I have never heard before, but I gotta say, this is kind of blowing my mind a little bit. He's saying the real problem of humanity is the following. We have Paleolithic emotions, medieval institutions, and godlike technology, which I feel like this has never been truer than it is now. And certainly, I'm kind of blown away by that quote. I think this might be the quote of this modern AI era. It really captures exactly what we're dealing through. We have people with emotions running amok, with, fears and greed and all sorts of like short-term emotions and drives that might be causing harm. Medieval institutions, a lot of the people that are the lawmakers, not necessarily the most tech-savvy people. Some of this stuff is just kind of like, just keeps going on momentum from very long ago. Certainly there's stuff that can be improved. And during this whole time, we have this emergence of, really godlike technology, I think is a good way of putting it. That's a heck of a quote, I got to say. But Dr. Jim Fan continues, the good news is we get to build the technology, which means we also get to define the role it plays in our institutions, societies, and cultures. AI is an inevitable part of humanity's future. It can be a tremendous force of good if we choose to apply the right force. Happy New Year, everyone. But let me know what you think about this. Are you excited for 2025 and the AI revolution, the robotic revolution? Are you a little bit worried and nervous? I got to say, this is a heck of a quote. I think I'm going to be posting it quite a bit here and there. With that said, if you made it this far, thank you so much for watching. If you enjoyed it, hit like, subscribe, more stuff coming soon. Same AI time, same AI channel. My name is Wes Roth, and I'll talk to you next time.